Hello, everyone. I'm Alireza Abdolmaleki. It's been 6 months since I started my PhD at Swinburne University of Technology under supervision of Dr. Mehrnoush Latifi and Dr. Pantea Alambeigi. My topic is a performance-based design framework using machine learning. I'm going to present this presentation in four main sections. A quick introduction about myself, what I've been doing during these past 6 months, and current progress and future direction this process might take. So I took my bachelor's degree in civil engineering, then I headed toward a master in civil and environmental engineering, and currently I'm doing my PhD, which I'm not sure how can I define its title in one word or expression. My master's thesis was about integrating energy optimization with LCA and circularity in a way that we defined a material database. This database was used for 3D modeling the building, and then this 3D modeling was used as an input into a feedback loop between energy optimization and LCA. The final output was evaluated through circularity assessment, and if it met the set criteria, we would have reached to the regenerative model. If not, we would have go back to the material database and tried some alternative materials. In another project, we looked at addressing both the humidity and temperature in a space by doing a numerical modeling and using a physical prototyping in a lab to evaluate the results from the numerical modeling. I've also contributed to a project that we designed an adaptive facade, which is controlled by machine learning. We defined a set of sensor grids and gather the data to train the model. Then using an optimization algorithm, the optimization would find the best position for these attractor points to adjust this facade structure to maximize the daylight while minimizing the glare. So that's how I end up in Synthetis Lab inside Arcmano and working on topic 3. And Synthetis Lab, as you know, it's focusing on the integration of creative operational processes and practices in design, developing workflow softwares and design tools to enable design processes to leverage data and automation, and developing new knowledge and new automated workflows and machine learning augmented tools to support design for advanced manufacture. Topic 3 is more focused on optimizing 3D modeling workflows, leveraging AI and machine learning in design process, and improving team collaboration on shared models. So the main question of my topic is that how can technology be used in AEC sector to optimize data organization, collaboration, and content sharing? Using this question, I started my literature review with the keywords that was mainly in 3 main categories: from information management, 3D modeling, and combination of AI and machine learning. This is the keyword heat map of the resulted articles. That's one of the main categories of these articles was 3D modeling and data management, and the other was computational design and AI and machine learning, which these two was the main focus of the research. Also, it has connections to immersive technologies and industry 4.0 digital infrastructure. So I use the overlap of these themes and goes through the second part of the literature review, which the main themes for the second set of articles was the data science, performance, computational and parametric methods, and environment and sustainability. So that's how I reach from the main question to the current topic, which is a performance-based design framework using machine learning. But during these past 6 months, I've faced many gaps in the literature. For example, one of the main important gaps is that most of these performance factors are being evaluated in silo and their interconnections are being neglected. And there's an uneven focus among these performance domains. For example, even energy studies often evaluate the energy by itself and doesn't care about the interconnections that it might have with other aspects of the building performance. So this suggests that there is a huge need for a more holistic life cycle based approaches in this area. But one of the main problems is also the insufficient high quality data sets and limited interoperability with BIM for earlier stage design decisions. So I define the methodology for my research, I use research through design, which, as I explained, a literature review is initiated. And this literature review helps to defining a case study. By doing this case study, at the end of it, the insights and data that is gathered helps back to defining the direction of the literature review. And this process, I mean, the information from the case study and the literature review works together to define the second case study. The whole process repeats again, and it defines the next case study and next to we reach the solid evidence at the end. One of the first case studies that I was a part of in my PhD was the structural carbon belt that we extracted geometrical attributes from structural elements and merged it with structural analysis insights from Crombo 3D and built a unified dataset that further on this dataset was used to develop, fine-tune a large language model for the designer to be able to interact with it. For example, designer could ask, hey, this is my design, how can I optimize it? And then the machine would be able to give some suggestions to the designer. So now I'm just basically trying to narrow down the scope and define more related case studies to be able to define and reach to a conclusion. Another case study that I'm currently working with Cox is maximizing carbon reduction through prefabrication, which it's been estimated that by 2050, the amount of embodied carbon for building construction is going to be double at this rate. And there's a huge impact that early stage decisions could have on the outcome of a building and construction process. And machine learning even could facilitate it and magnify the impact of early design stages as well. So in the process, we're going to define, gather a data set. This data set we'll use as an input to train a machine learning model to predict the embodied carbon for a structure. And then a genetic algorithm will find some optimum solutions that can give as suggestions to the designer. And the designer could have more informed decisions in the process. So the objectives would be to predict embodied carbon in earlier stage without the need for a full LCA, identifying carbon hotspots, and suggesting low carbon substitutions and providing real-time feedback to the designer. Another case study is a topic I'm going to present in the next hackathon, which is a multi-scalar optimization of the facade, integrating daylight, energy, and life cycle carbon. As I said, there's a need for a more holistic life cycle-based approach in performance-based design. For this hackathon, we're going to aim on a facade structure, but not only to look at the daylight, but the effects that the materials could have had on the energy as well, and also on the embodied and operational energy at the same time. So for this process, we will be using parametric design and machine learning and optimize it through the multi-objective optimization processes. Thank you very much for your attention. And I would love to hear any comments if you have. Thank you very much.
Good, thank you very much for your presentation. Questions from the audience? David.
Thank you for your presentation, really interesting, and I think it's a fascinating topic and really important. And it seems to me that certainly with machine learning, there's scope for amazing innovation and new ways of understanding buildings and also optimizing them with environmental performance and so on. I just want to say that basically we had just had a PhD who just submitted her thesis, Juliana Croffey. We published some things from her PhD together, and she did that. She did that with like the first thing. She did a machine learning tool. She developed a machine learning tool to get early stage assessments, environmental performance assessments of buildings. So I think it's definitely worth definitely have a look at that.
Sure, definitely.
And I guess, so I think this is a really valuable topic, and I just wonder, so I feel like I'm sure she's not the only one who has done things in that direction. So I just wonder how you, how you sort of define the scope of, I mean, I think there's probably also worth having a kind of bigger perspective on what is actually, so is that, you know, if your PhD is more on a bigger perspective on how can you use those tools and evaluating that, or is it more on a specific aspect, you know, using a tool, developing a specific tool to do a specific thing? So I guess that would be my question, you know, how you navigate that. So you're not, to make sure that you have your gap, right? Like, and your specific contribution. Yeah. I mean, is it, for example, I don't know if anybody has done this for facades specifically, so, or, yeah. Mm-hmm.
Thank you very much for your suggestion. And I think that's a really good question at the end. That's pretty much what I'm aiming at this point, because it's just 6 months that I started this PhD, and exactly this is the current struggle that I'm facing, and I'm trying to narrow down the topic to reach to one aspect, or maybe and its related contributors to that aspect, to analyze them as one. But yeah, that's what I'm going to, not to analyze all the tools that have been developed for this, but to develop and one main scope for this, which it's still in progress. I'm hoping to reach there. Yeah, thank you.
I thought that was a perfect distillation of someone's early stage doctoral research. So congratulations.
Thank you very much.
You mentioned adaptive facades.
Yeah.
Is that an important part of your research?
It's one of the projects that I was a part of with a couple of my friends, basically. We worked, it's not, it's from my master's.
Yeah. So I'm at the sort of twilight years of my career, and it sort of started with the Jean Nouvel Institut Mondial in France, which had sort of diaphragms that would, and exposed the world to technical frailty. And so I've been very interested personally in adaptive facades, which don't have a high reliance on mechanical components. So I wondered if you would be able to bring your earlier research into this, because I don't know how many facades there are in the world that are genuinely adaptive, but I would have thought it's the future in terms of seasonal variation, diurnal change, you know, sun moving around. And I mean, there are historic precedents of typologies where winter sun goes in through a porch to warm a back wall, but in hot summers it's in shade. So my suggestion is that if you want to even further enhance and also drill down, looking at opportunities for adaptive facades that aren't highly reliant on technology will give you some interesting parametric variation.
Thank you very much for your comment.
On the question.
That's really, really glad to hear that. Thank you.
Good. Are there any other questions? Of course, without seeing the topics, your topic and Mari's topics before, if two people talk about facade and machine learning, I think there's a lot of kind of synergies there as well. And we hope that through the presentation today and the symposium, the PhD students get a chance to better see what everybody's doing. Because you're based in Melbourne, Mari is based here in Sydney, we've got other PhD students in Adelaide. And of course, we don't really speak daily about your PhD topics. So to all the PhD students, if you see a certain similarity or an opportunity to work together, by all means do that. That's the main purpose of the symposium, to bring you together, to give you a chance to meet you personally and to exchange ideas, but also starting partnering on your PhD. Not that you do one PhD together and get two out of it, that's not an option, but then there's also a life after the PhD that you start slowly building up research partnerships with different other PhD students in your cohort. Last question, last comment. We can do that, but we also can do that over lunch, because lunch is coming, and the lunch is prepared.